Today we're talking about 4.2. We're graphing quadratic functions either in vertex form or intercept form. Now remember, we've already covered standard form, and we talked briefly about vertex form the other day. Let's focus on the vertex form. The objective for today is, by the end of this lesson, I will be able to analyze different forms of quadratic functions and use the differences to graph their parabolas. What you need to do right now is Google, how is quadratic functions used in real life? If we take a look at the new form, the intercept form, you will see that it's not that much different from the previous forms we've had, except for it's written out as a product of factors. We have A still, and it still informs you if the graph is going to have a maximum or a minimum, meaning if it goes up, the parabola opens up or the parabola opens down. And then we have this P and this Q. Now these P and the Q, it represents the x-intercept. What is the x-intercept? From Algebra 1, the x-intercepts are the values in which the graph intercepts, meaning coincides or hits the x-axis. So if it's written in intercept form, the intercepts will always hit it at P, Q or at Q, 0. In order to find out the axis of symmetry, you use that P and you use that Q. You add the two together and you divide by 2. If you remember from Algebra 1, it's where the graph hits the x-axis. Let's take a look at the first example. Find the axis of symmetry, the vertex, and the x-intercept of the quadratic function below. Now, you know from your previous experience when graphing quadratic functions, you need 3 things. You need to find out the vertex and the axis of symmetry, and it will help you by looking at A to understand if the parabola is going to open up or open down, because again, when you're graphing, you want to have a clear visual of your picture. So identify, what form are we working with? Are we working with standard form, vertex form, or intercept form? Yes, we're working with intercept form. Now we proceed with using that form to help us analyze the problem. From here, I know that I'm already working with intercept form. So the form says that A tells you if it opens up or down, and P or Q are the intercepts. Now I'm looking at the problem. Y is equal to 2 times the quantity of x minus 2 times x minus 6. I need to identify what my P and Q is. P is 2 and Q is 6. Look at the positioning. So all I have to do now is write it as a coordinate point. Remember, when you're talking about intercepts, the y value for the x-intercept is always 0. So my coordinate points are just going to be 2, 0 and 6, 0. From here, I know that the standard form for... So now we need to find out the axis of symmetry. Thank God we already know what P and Q is from the previous problem. Remember, P and Q represents the intercepts of the graph. P, again, was 2 and Q is 6. Now, from the intercept form, it tells us that in order to find out the axis of symmetry, all you have to do is add P and Q and divide it by 2. So good, I'm just going to add 2 plus 6, which is 8, and divide that by 2, which is 4. So my axis of symmetry is going to be x equals to 4. That is where, again, the vertex is going to be on that line. Remember, that's going to identify where the graph is going to open up or open down. Now, if you look at A, which is 2, you should already know whether or not the graph is going to have a maximum or a minimum. Answer that question. The last part figuring out the vertex. That point. I'm going to ask you to think about how we figured out the vertex of the previous problem. It was easy when it was given to us in vertex form, right? But in standard form, we had to do a little bit of more work. What happened when we used the formula x equals to the opposite b over 2a? You found that value, and what did you do with that value for the axis of symmetry to find out the vertex? That's correct. We had to substitute it into the original problem. The same thing with this situation right here. Once you find out the axis of symmetry, we're going to substitute it into the original problem. Now, again, we just found out the axis of symmetry, which was 4. Now I'm just going to substitute that x value into the original problem, y equals to 2 times x minus 2 times x minus 6. 2 times 4 minus 2 times 4 minus 6. Order of operation tells me to do the parentheses first. So I'm going to subtract 4 minus 2, which is 2. Then I'm going to subtract 4 minus 6, which is negative 2. So now I have a set of products. 2 times 2 times negative 2. Now, of course, you know that associative property says it doesn't matter which order you're going to do it from, but I'm going to do mine from left to right. 2 times 2 is 4. 4 times negative 2 is negative 8. So now my vertex occurs at 4 comma negative 8. So what was the step? Step 1, find out the intercepts, which represent P and Q. Step 2, find out the axis of symmetry by using the intercepts P and Q, add them together, and then divide by 2. The last step in order to find the vertex is you substitute that value into the original problem. Let's try some practice problems right now.